Welcome to this explainer. If you've looked at the price of a new computer or smartphone lately and literally felt your jaw drop, well, you're definitely not alone. Today, we are acting as forensic diagnosticians to uncover exactly why your tech is getting so incredibly expensive. And to make sure we get the complete picture, we are going to go through our source presentation page by page. We are not skipping a single slide or leaving any page out. We're going to decode the exact mechanics of this crisis piece by piece.
So here is our roadmap for the breakdown. We'll hit the abnormal surge in memory prices, the butterfly effect of the 2023 squeeze, the physical limits of AI memory, the reverted power dynamic, and finally, the entirely new paradigm of the memory market.
All right, let's jump right into part one, the abnormal surge in memory prices. To really decode this so-called Ramageddon, we have to start with the immediate impact on you, the consumer. We'll explore exactly why giants like Apple are suddenly jacking up baseline prices, how the whole AI boom essentially broke the supply chain, and what the new rules of semiconductor economics actually look like right now.
The real-world damage? It's already here, and it's a massive $1,300 symptom. Apple recently had to hike the price of their top-tier Mac Studio from roughly $4,000 up to $5,299. iPads, MacBooks, they've all jumped by hundreds of dollars. And why? Simply because the cost of memory is completely dominating the bill of materials for high-end hardware. Plus, it's not just computers. JP Morgan projects that by 2027, memory alone is going to consume over 45% of an iPhone's total material cost. That is absolutely wild.
And here is the why behind it all. The sudden expansion of AI data centers has triggered an estimated 1 millionx increase in global computing demand in just 24 months. You're basically looking at infinite demand slamming into finite supply, which has totally shattered the pricing equilibrium. We're seeing a 6x surge in specific memory spot pricing over the last year alone, and a projected 98% jump in DRAM prices just by Q1 2026. Big tech used to use their massive purchasing power to pit suppliers against each other. But honestly, that leverage is completely gone now, thanks to extreme market scarcity.
Moving on to Section 2, we need to talk about the butterfly effect of the 2023 squeeze.
So let's rewind a bit. In 2023, there was this massive post-pandemic slump in PC and mobile sales, which created a huge inventory glut. Buyers saw an opportunity and ruthlessly squeezed suppliers, forcing memory prices down way below the actual cost of manufacturing. This caused a staggering hemorrhage for the suppliers. Micron alone recorded a $5.8 billion net loss. To just survive, memory suppliers had to physically slash wafer input by about 30%, delay new equipment, and entirely freeze their future capital expenditures.
Now, the catch here is that suppliers couldn't just temporarily pause operations. Semiconductor fabs have an incredibly heavy burden. 75% of their costs are totally fixed. We are talking about billion-dollar lithography machines and extreme depreciation that racks up whether the machines are actually running or not. So even when prices crashed, fabs had to keep producing just to recover a little bit of cash flow. But by late 2022 and 2023, prices tanked so low that even this survival strategy failed, forcing them to take the absolute last resort of physically cutting wafer input. The problem is, you literally cannot solve a 2026 memory shortage with 2026 capital. Expanding capacity takes 24 to 36 months of incredibly complex steps. You've got to secure power and water, build specialized clean rooms, and install those billion-dollar tools. Because all capital expenditures were frozen during that aggressive price suppression in 2023, it practically guaranteed a massive 2 to 3 year structural supply deficit. And that is exactly what we are driving straight into for 2026.
Okay. On to Section 3, the physical limits of AI memory.
To really grasp why AI memory is so insanely hard to make, think of standard RAM as a single-story house, a wide, flat layout. High bandwidth memory, or HBM, is like a high-rise apartment building. It's stacked vertically to feed massive datasets instantly into AI accelerators. But building this high-rise comes with brutal physical constraints. It needs a massive physical die footprint. It suffers from a TSV penalty, which requires microscopic holes to be drilled through ultra-thin silicon. And worst of all, it has a cumulative defect rate. If just one single layer in an 8 or 12-layer stack fails, the entire bonded unit goes straight into the trash, no exceptions. Which brings us to a frankly terrifying zero-sum game for these cleanrooms. Because HBM is so complex and inefficient to manufacture, producing just one HBM line eats up the wafer capacity of 3 standard DDR5 lines. Let that sink in for a second. Every single time a supplier fulfills a highly profitable HBM order for an AI data center,
They are directly cannibalizing and degrading the supply of standard consumer and server memory on the open market. It is a massive hit to the total bit growth for the broader tech industry.
Let's look at what this all means in Section 4, the reverted power dynamic and the aftermath.
Remembering that fixed cost trap we just talked about, we can truly appreciate the absolute bloodbath of 2023. Customers ruthlessly pushed prices down below the actual cost of manufacturing, which led to a negative 9.1% gross margin and that massive $5.8 billion net loss for Micron. Believe it or not, running the lines at a loss was financially safer than turning them off completely. But as we're about to see, this era of buyer supremacy was about to end very, very violently.
This supply shock we're feeling right now is essentially a delayed bill, unfolding in 4 predictable steps. Step 1, the 2023 squeeze. Step 2, the halt, where future capacity expansion was entirely frozen. Step 3, the 2024 AI catalyst, where compute demand exploded practically overnight, but new capacity couldn't be turned on because of those physical build times. And that leads us straight into Step 4, the 2026 supply void. This shortage isn't random. It is the direct mathematical consequence of those aggressive procurement tactics from 2023.
Now, the balance of power has violently shifted. Back in 2023, buyers held all the cards, crushing supplier margins down to negative 9.1%. Today, propelled by absolute pricing power and insatiable AI demand, suppliers are sitting pretty on a massive 84.9% margin. With limited cleanroom space available, suppliers are literally rationing output and prioritizing ultra-lucrative segments like HBM and enterprise SSDs. General consumer tech has essentially been shoved to the back of the line.
And for sure, this translates directly to the downstream impact on your wallet. For Mac hardware, because Apple uses high-capacity unified memory integrated directly with the processor, the memory cost per unit is exceptionally high, driving immediate $100 to $500 price hikes. And look at the iPhone. Historically, its price remained relatively flat because processor constraints dictated the volumes much more than memory did. But as JP Morgan projects memory will soon make up nearly half the device's cost, Apple's ability to shield consumers from this volatility is breaking down. Severe consumer price hikes in mobile are mathematically inevitable by 2027.
Which brings us to our final part, Section 5, the entirely new paradigm of the memory market.
We're witnessing a massive, industry-altering shift from a disposable commodity era to a highly strategic era. Tech buyers can no longer rely on short-term spot market contracts to exploit oversupply. Survival now requires multi-year long-term agreements, or LTAs. Under this new model, Micron has already secured $22 billion in massive upfront deposits targeting 2026 to 2030. In exchange, buyers get pre-allocated capacity. Risk is now explicitly shared, featuring guaranteed price floors during a bust and price ceilings to protect buyers during a boom.
Here is the real aha moment of this whole breakdown. Memory is no longer just a component you toss into a cart. It is shared infrastructure. The old era of transactional antagonistic procurement is totally dead. If tech giants want a guaranteed, stable supply during the inevitable AI peaks, they must step up and pre-fund the capital expenditures in the valleys. They have to co-fund the clean rooms.
Ultimately, memory has become a critical capability that tech giants must financially underwrite just to survive. Those recent price hikes you're seeing from companies like Apple, they aren't simply a reflection of sudden AI greed or basic baseline margins. They are the realization of a delayed invoice. When buyers refuse to share the financial risk during a market crash, they inevitably end up paying the premium during the boom. That is the true cost of stability.
As we wrap up this explainer, having gone through every single piece of our source material today, consider these 3 key takeaways. First, the inflation we are seeing in tech is structural, not cyclical. It's the mathematical result of HBM bottlenecks, and it is not going to self-correct quickly. Second, procurement has to evolve. The old playbook is a major liability, and survival demands upfront capital commitments. And third, managing memory supply is now a core corporate competency. So I'll leave you with this final provocative thought. If securing memory assets is now the fundamental bottleneck to product viability, what happens to the massive tech companies that fail to pre-fund their spot in this new closed ecosystem? Thank you for joining me, and keep questioning the tech you use every day.